Hi, I'm John, welcome to the channel, and this is my kind of build overview of the E-Wings Blackhawk. I've done a few things a bit different to sort of stock to the manual. Thought I'd take a few minutes to take you through what I've done and how I've built it, share some ideas which might be useful for wings in general that you're building, or inspire you to come up with some ideas of your own. I wouldn't necessarily recommend that everybody tries everything that I've done. It's not going to be right for everybody, and some of it's just a lot of extra work with questionable benefits, and some of it is definitely adding extra weight. So in terms of, I guess the most obvious thing with this is I cut the nose off. So there is a mount on the nose. You can't really see it. There's sort of a lip there, and the nose is clip onto it. So I've got different noses. I can put whatever nose I like on, and looks a bit weird in the camera view. And swap it over. It just has two M3. It slots. Can't find my words. It slots on and has two M3 nuts in the nose, which then you can see the screws here. So you can just screw those on. So they're pretty secure. What I've done now actually is I've also printed this mount out of TPU. The original one was PTEG, and it was very cold. It was sort of, I don't know, -1 or so, and I was flying badly and doing silly manoeuvres at very low speeds and tip stalled it, and took a nosedive and smashed that, broke off. So I've now printed it out of TPU, which I figure will also absorb it a bit more. What was great was I'd used Gorilla Clear to glue this on, and which was a suggestion from Greg, and I was able to rip it off and not damage the foam. I might have a picture insert if I do. So one of the first things I knew I wanted to do was have an interchangeable nose. So to do that, I thought I will extend the lipo bay further backwards, because with the weight of the nose I might need to move the battery further backwards. So I cut the centre out the foam. I think I cut about 45mm back, but basically the spar hole through the centre of this is now dead middle of that block of foam, to allow me to move the battery further back. At the same time, I was kind of conscious with taking a big chunk of foam out of here, I'm effectively giving the nose more leverage if I take a bad nosedive into the floor, which, let's face it, is going to happen one day, and snap the nose off. So I thought what I would do is reinforce that. So I cut the centre out of the foam, glued the sides on. I used the centrepiece or the front nose piece that I'd cut off. That was just cut off level at the end of the lipo bay, and then cut the sides off to match, to space this apart when I was gluing it. Once I'd glued that, I have a picture I'll be able to insert because you can't see it, but in each sidewall I cut just cut a line in the bottom of each sidewall and inserted it's 5mm by 1mm carbon strip, which runs all the way down to give it extra strength. And I've also put a couple of strips of reinforced tape down each side, just to strengthen the bottom as much as possible, before I laminated it in 75 micron laminate. So I laminated the bottom and the top, and then folded them, made some slits and folded them down the side so you can see the slits on the side if the light's right. So that was kind of my main thought around the nose, trying to achieve that. I have then, you can't really see it, but I've cut a slightly larger lipo tray. I'm lucky enough to have a laser CNC that I recently got, which is brilliant for that kind of thing. I've also added these lipo lid rails to hold the Corex perfectly in place. I don't think it's necessarily needed. I've got some little magnets that I'll probably put in here at some point, but it's actually pretty firm. And then one tip that I would recommend, I don't know if it's going to come out on the camera here, but where potentially I'm going to put the strap through, you can see I've run reinforced tape because it's sticky through here, but it means the bottom's curved and the foam is smooth under the fibre, so it's really easy to thread a lipo strap through. Normally, because you've got a sharp 90-degree bend and the Velcro catches on the foam, if you try and run a lipo strip under your battery bay, once it's glued in, it can be really fiddly. If you run a piece of tape and just curve it in the end so it's not stuck quite into the corner, you'll find it smooth and it naturally bends the lipo strap round to get it round the corner, so it's really easy to thread it through. Obviously weighs next to nothing and just makes life a lot easier if you need to move the lipo straps or take them out and swap them. Then the other thing I'd say just about prepping the foam is you do not need to do this at all, but I like to run over the foam with good old-fashioned greaseproof paper and a laminating iron at about 180 degrees and basically laminate the greaseproof paper to the foam almost, and it smooths it out really nicely. You can see actually where I've cut it here. I've used the same trick just to get this completely flat after I cut that piece off, but I tend to do the whole thing. I just personally have found that I do a better job of laminating when the foam's smoother to start with. I think I've got a picture of the sort of impact of doing it. What I would say is you can laminate it and run a hot iron over it, and that will smooth it as well. Personally, I've just found it's more work, but I've found it easier, and I've sort of done it a couple of times now, so I like the result I get from it. So I do that. Just make sure it's cold before you rip the greaseproof paper off, otherwise it will rip foam off with it. And then I guess the next thing to talk about would be the wings, I suppose. So I am planning on trying to get this as fast as I can, basically, and the wings are friction fit. Now, I think that's probably fine, and I've not seen anybody have any issues with it at all, but I'd been playing around with mine and the front just felt like it had a tiny bit of movement. If I pressed it, it didn't wobble around normally, but I thought if I'm going to be trying to go silly speeds, I just felt for a peace of mind I wanted to secure them a bit more. So I created these clips to clip them on. So it's basically, this is P-TEG, it could be PLA or anything. Two pieces that go into each side. I've got one that's not in the wing, and you can see, if I can get that out one-handed while I'm filming, it's just got a kind of round groove in, and this clips into it. And then I've got just a slot here, so you can I do it one-handed? Yeah. So I've got a TPU strip here that will come out to enable me to slide the wings off. Now, yeah, you can see. So I can slide the wing off, and then that clips in quite firmly. So that wing is like not moving at all, it's rock solid. Now, there's obviously, if you do that, you've got to make sure you cut that dead level, and also allow it to stick out through the thickness of the Corex, because otherwise you're going to be squashing that. I would also say that you could glue that on with Gorilla Clear, which has probably been a good idea, but with the tension on it, because under tension I didn't know if it might start to pull it. So I've used E6000 glue, which means if I crash, my wing is not going to move, and it is probably going to rip out a big chunk of foam with that, because that TPU is sort of 4mm thick, and it's probably not going to give it a crash. I mean, I think there's a little bit of spring in it, but only a couple of millimeters. But I'll share the STL for that if anybody wants it. But obviously it's kind of at your own risk, because if you crash rather than the wing come off, you're probably ripping out a chunk of foam that you're going to have to glue back in. And then the other thing I've done on the wings is you'll see the servos are mounted in the bottom of the wing. So I'd seen Josh Galt apologies Josh if I'm pronouncing your name wrong, had hidden servos in the wing on a mini Drac he was building and wanted to do something similar. He'd got them in the top in a kind of plastic mounting bay, which would make more sense, but I thought I'd put them in the bottom, and then I've got the horns going upwards, and I used just a screwdriver heated up to melt holes diagonally through. I sort of guessed from the side the angle that they were going to need to be, melted those through for the control rods. These are ridiculously 5mm carbon rods because I had these 5mm couplers, so that was what I used. The other thing I would say with this is, because rather than run the control rods at 90 degrees to the control surface, if you watch when they move, there's left and right. I'm trying to move the camera straight over it. There's left and right movements in the servo horn. You can see one side and then the other. So these are Robart. I don't know if I can focus on that. Robart ball link hinges, and in here, which you can't see on this camera, rather than just a hole, there's actually a ball link in the control horn, which I really like. So you can get those. The only place I know that sell them, I'm sure there's more, so add them in the comments, is I think it's Nexus Models sell them in a variety of heights. So I've done, so I got those working. I did, when I was doing that, I was test fitting the Elevon, like gluing it on with, sticking it on with kind of just some spare tape temporarily to line it up and make sure I'd got the angles right and things, and making sure I'd got the right movements and it all worked freely before I did anything, because once I'd glued the servo in, that's obviously going to be really hard to get to that servo horn without starting to really rip things apart. And then also I made my own Elevons, which I'm sure there is no need to do, but I'm going to blame Mr. Price for this suggestion, because he was saying I should put the effort into making tapered Elevons, because I have on most other things. So you can probably see the Elevons are tapered. Actually just cut them out of some trailing edge bolts that I had. Now, because they're thinner and the control horn is further over to one end, I was worried about how much flex there was going to be. I mean, they're pretty stiff now. So some of that I think it was 5mm carbon strip that I mentioned earlier I had, and it's actually got a strip of that running across the top of the Elevon to stop twist. Me shaking the camera does not demonstrate twist very well, but to show the twist. So what I did was put the strip on top of the balsa, ran a craft knife down each side, sort of about 1mm deep into the balsa wood, and then if I've got a picture, I'll add it on. I sanded the edge of the carbon strip, or the end of the carbon strip, into just a chisel point. It's really easy to sand it, and used that as a kind of chisel to gouge out a channel to glue the strip into, so it's sort of routed into the surface of the Elevon, and then that's stuck on with the old hinge tape method. And then what else to say? We've got wing protectors, which the STL is I guess Greg will put it on the E-Wings site, but it's also on the E-Wings Pilot Facebook page if anybody wants it. The Corex fins, just for extra rigidity, I think you'll see it if I hold it up to the light. You can just see there. It has got a 3mm carbon rod running through the Corex glued into it. And then the other thing I did was, I was thinking about creating 3D printed skids for the bottom, but I just thought it's less aerodynamic. I'm trying to keep it streamlined. So I got a chunk of a 4mm wide zip tie, long 4mm wide zip tie, and actually glued that on, put a bit of fibre tape over the top of it as well, just to make sure it's reinforced. So the bottom of these skids are a bit reinforced if they hit stuff, which invariably they're going to at some point. And then I channeled, I've got crossfire antenna, and I thought I'd try, this is a Vaz Crossfire Pro antenna, which again I cut out a little bit so it's perfectly smooth in the wing. We'll see how I get on. So far it's been good, but I've not been that far. And then I've got a Rush Tank VTX in here with an axis side feed antenna. And this mesh is actually off the front of a Rambler. Best thing to come from the Rambler. And then what else can we say? Oh, we've got airspeed sensor. Where's my screwdriver gone? So again, tricky to do 100. Let's just take that wing off. I've got just some connectors. Apologies. Just some connectors to hold the wing on. So if I take that wing off, connectors to hold the wing, connectors to connect the servo and the receiver. You can see I've put the airspeed sensor in the side of the wing, and I guess when you can see that, you can see I've actually cut to fit the plugs in a bit of a chunk out the side of the centre of the foam and a little bit more out the Corex, and then that ridge is obviously cut out to go over the joiner. So I think those are probably the key points of the wing and the build. You can see they're sort of flush into the back, so I cut out some holes in the back and sunk LEDs into the rear of each side of the sort of centre wing, I suppose you'd call it. And then the other thing to talk about is the motor. So I wasn't sure which motor to run, and had different ones on order that didn't get delivered. I wanted a 2814 size stator, and the best I could find at the time was a 1200 kV one. And then Hobby RC got a 2000 kV one in, which I've been running. But equally I thought, well, it might be nice to run the 1200 kV one on a higher voltage or a bigger prop for a bit more efficiency if I want to cruise. So I created this motor mount that takes 5mm bullet connectors. You can cut the motor wires, you have to cut them pretty short. And then it literally plugs in and out to the motor mount. And I've got this as a sort of a test one. You can see this is a bit narrower. I sort of extended it so there was a bit more on the side of this to glue onto the fuse. So the bullet connectors go in here, and I actually melted some holes through, well, a hole through from here coming out under here to run the motor wires to the ESC, which is obviously quite tricky soldering because I cut those and soldered those in place there. So the other thing I would say is, again, I'm happy to share the STLs for this. Effectively, I can just swap the motor with these 4 motor screws, and then on the edge you can see I've got some nuts that sink into the motor plate, and they don't, you can't say that they don't press against anything on here, so you can screw a couple of screws in to pull the motor plate out, because the 5mm bullet connectors are a pretty snug fit, which obviously you want them to be a snug fit as well, to make sure you've got a solid connection. And then there's plenty of airflow to the stator, so this should still fit on this one, even though it's an older design. You can see there's plenty of airflow at the top and the bottom. You do have to cut a sort of bit of a groove out the top and the bottom of the fuse to fix this motor mount on. To be honest, unless you want to change your motor, you're probably better off going with the conventional motor mount. This is going to weigh a bit more, but for me, I'm planning on doing silly things with the motor, so the extra airflow and being able to swap them over is quite nice. I can do one of these mounts. Originally I did a mount like this, but without the bullet connectors in. So if anybody wants to use this mount but doesn't want to use the bullet connectors, they can do that. It's even got a sort of bit in to run zip ties through, so you can thread some zip ties through and zip tie the motor wire to the back of the motor plate when it comes out, so it's not pulling off the motor. That's obviously just a little sort of 3D printed box. I've put the ESC in, and then the ESC wires come out into the motor, and there's a lot of capacitors in there, probably more than I need, but I already blew a 50 volts 470 microfarad capacitor, so I thought I'd put a couple of more on. I had a bit of a problem with some video noise to start with. Not much else to say about that really. GPS is in the wing. There's a little hole, you can't see it, for the LED light because I cut out the foam and then put the top piece back on just for neatness. On the VTX heatsink, comes out the top, it's flush at the front and it's sort of raised at the back. Hopefully try and reduce drag as much as possible. And then the other thing I wanted to talk about was the noses. So the noses themselves, so far, if anybody wants to do this, I would happy to share the STLs. I would definitely say print the noses before you start chopping stuff off, because depending on your battery and all the rest of your setup, is going to affect whether you're going to hit CG. Because I've obviously got these bullet connectors, this bigger mount on the back, I've got a bit more weight on the back, so I can still hit CG with a little bit more weight on the front, plus I've extended the LiPo bay back. So I've got the standard nose, which this has got Runcam Phoenix in. The nose is printed on the side. I printed them out of P-Teg. It's not too tricky to print, but you've got to add supports manually. You can't see this. There's basically two plates in here, so I ran a support up the middle, just as far as the second plate to support that, but not all the way across, just kind of a block up the middle. And obviously you need to support the underside of that to print it out. It was a little stringy inside, but it works. I've printed a couple now. And then what's the next one? So we've got GoPro Session mounts, which again has this has got Phoenix 2 camera in, and then the GoPro mount itself prints in a couple of parts. You've got a kind of protective bumper that's printed out TPU, which you don't necessarily need to use, but GoPro Sessions are like gold dust these days, so I don't really want to break one. And then you can see you can access the button and see the display and stuff from SD card from the top. And then to remove the session, because obviously it's completely enclosed for protection, there is like an eject button on the bottom, which hopefully you can see there. So if I press that, the lid pops off and it pops the session up, so you can actually get the session out. And that's actually it's not coming out on camera very well, but that's a print in place hinge, so that will print in place. And then the other thing to mention is there is a little TPU piece you need to print at the back. So rather than fill the whole back up with print to support the back of the GoPro, which is obviously going to weigh more, this fits into a couple of little slots top and bottom, and it provides really needs to be out flexible filament, and it holds the GoPro in place quite nicely, but in the event of an impact there's obviously some give to allow the GoPro to move back. So the tricky bit with printing this is you print it on its side. You don't want to print it with loads of supports, but you do need to add a support on the STL. This is kind of, the button is open if you like, so you need to add a support on the inside, but make sure to support that so it can print, but make sure the support isn't in the hinge, because otherwise the hinge is going to print solid. So that's a little trickier. You just got to take time thinking about where you're putting the supports, and again you'd sort of print it that way around. And then the final nose is for a Hero 8. So it's got two catches, which so I can't do that on camera very easily. It's got two catches on this lid with kind of a double hinge that prints in place, so it prints this way around. And again, when it prints, you'd need to add supports from under here to hold the door. And then again, there is a print in place eject button on the bottom, so you can actually it's tricky one-handed, get the Hero 8 camera out. The only other thing with this is because the Hero 8 is quite big, the FPV cam sort of slots in here. I've put the cable out the back, and you have to put it in upside down so the plug is on that side, otherwise the plug would be in the way of the Hero 8. So you have to put it in upside down, and then in the camera settings invert the image, which is fine in a Phoenix 2. I think you can probably do that in most cameras now, but obviously that might restrict your camera choice with this kind of nose. And at the moment this is just held in with a dab of hot glue, because it's such a slight angle there, the screw hole would carry on sort of most of the way across, so I decided not to put screw holes into that one. And then any of these will clip on. They take, I don't know if you'll be able to see through there, maybe you can just see that hexagon, but they all have M3 nuts in, and then the nose screws on. I am going to work on a Runcam hybrid nose as well, so I will make these available. They're not the easiest to print because you really need to manually place supports to think about where they're going to go. So if anybody's thinking about doing this, I would definitely try printing the nose first, make sure you can print it and you're happy with how the print comes out, and everything works with it. In fact, I should mention on this one, when this prints, there's a little join each side of this catch just to support it while it prints. You can just press it and it'll crack, and then the clip will work afterwards. So I've not had the chance to fly this as much as I'd like to yet with everything going on at the moment, but I've had a couple of packs through on the 2000 kV motor on 4S with an 8x6 prop. It was just scraping 140 miles an hour. Nothing was coming down crazy hot, but it was freezing, so I guess we'll see what it's like on a slightly warmer day. Had a really shitty 4S packing that's 12C rated or 24C rated for burst current, and I think I was probably putting north of 100 amps, so the pack was just sagging like crazy. So it'd be interesting to see what it does with a better pack. I've also tried it with a 7x6 prop, an APC 7x6, and that topped out at about 125 miles an hour, pulling about 50 amps. If the current sensor that I haven't calibrated at all on this iFlight ESC works. Now, weirdly, the following flight I have had some electrical problems with this. I sort of swapped to this 7x7 prop to try, pad it up, got to about 30% throttle, and the ESC just died, nothing went pop. Don't know what's wrong with it, so I need to change the ESC before I can get out and fly. Well, plus and lockdown needs to end, which is a bit shit, but anyway, can't wait to get out and test various different prop combinations and LiPo combinations on that. But hopefully that was useful, interesting, gives people some ideas. Always interested to see what people do for their builds. Thanks for watching.